Do you mind turning off the front lights here? Okay, so how was that? How was number one? Is that okay? That was literally going backwards. You just had an example, so I'm going to skip that one. It's 75. If you didn't do it, 75 sides. Number two, let's do this one. So if I tell you that it's a pentagon, immediately you should know that n is equal to 5, right? And it has the following interior. Read this carefully. Interior angle. So whether I say interior or exterior, it makes a big difference. If I told you these were the exterior angles, what do we know about exterior angles? What do they always add up to? Not 180. The exterior angles always add up to 360. Always. Okay? Could be a centagon. I'm just making this up, right? 100-sided pentagon. But in this case, it's interior, okay? So determine the fifth interior angle. To do A properly, you need to start with this one. The sum of a pentagon would be 5 minus 2 times 180, just like that. That'd be 3 times 180, and that's 540, correct? So we know that all 5 add up to 540. So this is definitely not a regular pentagon. I don't know what it really looks like, but you've got 100, 102, 99, 105, and this one is missing. Okay, so just like with a triangle, if you want to call this the fifth angle, you go 540 minus 102 minus 99 minus 100 minus 105. So that's the 4 angles. That would be equal to 134, correct? Yeah. So that last angle that we didn't know has to be 134 if you want to have a pentagon. You have to think of it this way. If this hadn't been 134, the lines wouldn't really meet, right? So that it would be open there. It has to be closed for that to be a pentagon. So that's A. For B, determine the value of each exterior angle. So my key has it this way, right? You have interior, and then you just list them like that. This is the best way I know how to show this. Okay, so you list all your interior angle, and you know that at every single corner there is an exterior angle, correct? At every vertex. What is it for 100? It's 80, right? Because interior and exterior always add up to 180. So we know that it's 80 for this one. Okay. For this one, it's 78. For this one, 81, right? For this one, 75. And for this one, it's 46. Okay? So you've listed all the interior angles and all the exterior angles that go with every single angle. Okay? And if you add this up, this should add up to 360, by the way. Okay? You know for sure then you're doing everything right. Does it? 80 and 80 is 161. 169. Yeah, it does. It does add up to 360. So C, is this a regular or irregular? Explain. Okay, so this is irregular. Right. All angles are different, right? Different in measure. Okay, angles are not congruent, right? That's another way of saying it. What if you had 2 that were the same, though? Still not. 3? Still not. 4? 5? And then obviously we would have to check if the sides are also the same, but I would tell you that, right? But if it's purely based on angles, that's what we would answer. Okay? Does that make sense? Does that help? Okay. I'll ask questions in weird ways, so I'm going to test your knowledge. Okay. Calculate the value of x. This is a polygon. 1, 2, 3, 4, 5, 6 sides. So even if it's a regular polygon, we can still use the S formula. Okay, so sum of a six-sided is 6 minus 2 times 180. That is 720, right? 720 degrees if you do this right. So we know that 720 degrees should be all of these added up. Okay, so the proper way maybe to show this is to add them all up. Plus x plus x plus 20. Yikes. It is x plus 20, promise. And because all of them have a positive in front of them, I can just combine like terms. 1, 2, 3, 4, 5, 6 x. And you can do this, add these up. That's already 100, 180, 280, and 300. So just watch the signs, okay? So minus 300, you end up with 420 is equal to 6x. Divide both sides by 6. X is equal to 70 degrees. And so that's how you do. So every time there's a variable, guys, think about what do I know about how are these angles connected, right? Are they corresponding? Then they should be the same, right? In this case, they're inside a pentagon, so I know something about that they should add up to 720 and so forth. Keep going. I'm going to go to 38, and I'm going to park on this. I just assigned to 38, right? Yeah. And we're going to try some on 39 as well. So determine the value of the unknown angle measures. So all these letters have to have a number at the end of the day. You notice that this goes to the center, right? So x, for example, has two central angles in it, right? X spans from this dashed line to that one, but it's central. So all of these have central angles that make up that big angle, right? So M has how many central angles? 3, right? What about N? 1, 2, 3, 4. It'll be 4 central angles, but I'll show you the shortcut for N. Okay, there's actually a shortcut for it. So let's figure out the central angle. How many sides? 1, 2, 3, 4, 5, 6, 7, 8, 9. I count 9. So that central angle will be 360 divided by 9. So that's 40 degrees. This is very important. Okay, everything is going to be based on this 40 here. So angle X is 2 central angles, right? So that's 2 times 40. So that'll be 80 degrees. Okay. Angle M is 3 central. So that'll be 3 times 40. That's 120. What's the shortcut for N? What is the whole circle around in the center? 360. So we could go 360 minus X minus M. Yeah, minus 80 minus 120. Yes. So if you didn't catch that, that's okay, but I want you to be aware of that. So this is already 200. So angle N would be 160 degrees. Okay. So I found all, and I clearly labeled which one is which. Okay, so I can clearly tell you know what you're doing there. What about angle Y? What angle is that? That is the interior angle of this polygon, right? So angle Y would be N minus 2 times 180 divided by N. So that would be 9 minus 2 times 180 divided by 9. Angle Y is 7. Yeah, don't rush on these ones, okay? I know we just want to get the answer, but take that extra second. Y is 140. Yeah. 140. What about Z? Or Z? What is that angle right here? That is an exterior. So we know that exterior angle would be 180 minus angle Y, right? That'd be 180 minus 140, 40. Or angle Z would be 360 divided by N, right? That still works. That's also 40, right? So always remember, sometimes you have no choice but to use this one, but sometimes you do have the option to use both, okay? We good? Look alive, guys. Life is good. Okay, let's go to 39. I didn't assign it, right? Or did I? Didn't. I'm going to let you try this one a little bit. Struggle on your own, okay? Remember, if I told you you know everything you need to solve for this, believe me, you do know everything. You just have to do a little bit of thinking. So I'll take a little break here. I want you to find A, B, C, and D. And remember, there's the solid bold line that shows clearly what we're starting with, a polygon. And then we've got a triangle coming out of it, okay? So try that one. If you're confident that you got that one right, you can do 40 as well, okay? 39 to 40 for now. Quickly, just so you know whether or not you're doing this right, I will just show you the answer key if I have it. So I keep on making new things, and then it kind of throws off my key a little bit. But here is this first one. I'll just show you here, and you quickly make sure. I didn't, like, sometimes I miss things, so maybe if I missed your a thing on your answer key or on your work, you got to make sure you understand that you got to check this, right? A is an interior angle, right? So I use the formula for interior angle to get this one right here, okay? So that's number one there. And B, I recognize that B is an exterior angle. That's right there. And by the way, this angle is also an exterior, like this. You could call this B as well. So sometimes you just either call it that or put a number in there. And that's how I find C. C I find by using the sum of a triangle, right? Because these are the same. So I just go 180 minus 2 times whatever angle B is, because you have two of those. And so there it is, okay? And when it comes to angle D, I think that one you should all know by now, okay? D is comprised of two central angles. I called it X just to differentiate between this C. So if by any chance you have a variable that is already there, maybe change it. So I called it X. I found the central, and then angle D is two central angles, okay? There we go. I do think that there's a good point here. Technically, a central angle is 360 divided by 9. No, not 9, 7. It has many, right? So technically, when you get this central, you're not done yet. When you multiply it by 2, that's when you should round. And in this case, it ends up being 86 anyways, okay? Even though if you didn't catch that, it's the same, but just make sure you're aware of that, because if you don't, then you might lose a rounding mark. So if that's important to you, make sure that you account for that. This is the next question you had there. And remember, those triangles that appear, if it's a regular polygon we're talking about, they're going to be isosceles, because this is an exterior angle and that's an exterior angle, right? And if you have two angles that are the same, you are guaranteed to have an isosceles triangle. Okay, there's a relationship between that. I also tell you that this will be an isosceles, because if you go from the center anywhere, right, it's the same distance. So for A, that's a central angle. B, you've got 1, 2, 3 central angles spanning B, and C has 1, 2, 3, 4, 5 central angles that span angle C. How did you find E? Anyone? It's not the interior because it's just here, right? It's between this line. Interior would be this. This is not an interior angle. Divided by 2 because we know that A is 40, correct? A central angle is 40. And if this is E, can I call this E as well? Yeah, they're the same. So I'm going to go 180. Yeah, 180 minus A, right? Whatever A was, which is 40. That gives me 140, and I split that remainder in half to get my 70. So these two are each 70 to be specific, okay? That's how you find it when it's like that. So a lot of isosceles triangles when you have regular polygons, so use that to help you out, okay? We're good? And if you didn't get to it today, after today, sit down, try it one more time, think it through. There's lots of space. That's why I leave you a lot of space in your booklets. If you get it wrong, try it again, okay? It's not a big deal. And I'm pretty sure I have this scanned, so I'll post it as well if you need help with that. All right, let's move along. I will say this, 41 is still a really good practice. So for now, I'm just going to say try that. It has backwards. But I'm going to move on to the next part. Inscribed polygons. Okay. So page 41 is good practice. And if you want to prepare for the quiz, just do everything up until what we've done so far. The answer keys are posted. All right. I'm going to start a new video here.